Welcome, everyone. This is the AA Austin Homes Tour webinar series, and today we are talking with the creators of the Bull Creek Residence, Studio Steinbomer, and I will turn it over first, we would like to thank the sponsors, the underwriter, Alpha Granite and Tile, and our gold sponsors. And with that, I will turn it over to Patricia.
Welcome, everyone. Thank you for joining us on the annual AIA Homes Tour. My name is Patricia Borowitz, and I will be your moderator for today's webinar. Please feel free to put your questions in the Q&A throughout the hour. Jed Duhan will join us in a minute to chat about the Bull Creek Residence, designed by Studio Steinbomer, a dedicated and talented team of design professionals founded by Robert Steinbomer over 30 years ago. Robert retired, but today is a woman-owned architecture firm led by Amy Bramwell, Jennifer Frizzell, and Jed Duhan. They are committed to assisting clients in creating environments that are sensitive to context and the occupant's aspirations and needs. One of their most recent projects is Austin PBS's new headquarters, located on the Austin Community College Highland campus and open to the public. Jed, turning it over to you.
Thank you, Patricia. Hello, everyone. Let me get my screen set up here. 1 second. Okay. It's not showing up once. Oh. Okay. Is the screen showing now? Okay, great. All right, here we go. Thank you, everyone, for joining this Homes Tour webinar. As Patricia mentioned, I am an architect with Studio Steinbomer, but this project happens to be my own personal residence. And so I'll have some interesting insights to add to the discussion today. Also want to give a thanks to my firm, Studio Steinbomer, for all the great partnerships and work that we do. We're doing great things, and I'm very proud to be part of it. Also want to give a shout out to Benjamin Johnson at my firm, who really helped with the design of this project. I gave him a hard time with the model unlocking and messing up everything in the 3D Revit model, but he was very patient with me and we got through it, and I really appreciate all this help. Just to touch base on some of the sponsors for this house, starting with Ford, Stride Builders. I approached Ford early in this process of design and talked to him about this project, and you could see on his face when he started to realize that the architect and owner was the same person, and he really started to, you could see him calculated in the corner of his eye, like, do I really want to take this on? But he took it on and did a fantastic job, and I really appreciate his help. Also his crew and Mike Collins and everyone else who helped with the project. Low-end windows, I certainly gave them some big challenges, which I'll point out during the presentation. Appreciate their help as well. So I'll try to point out everyone's participation, like these different sponsors in here. But everyone in here had some serious conversations, solving some real problems during this project. So great appreciation to all of them. Okay, so I've broken up the presentation into 4 categories, but it's really, the way we would approach any project at the firm and how we would approach the design of any new project. It's broken up into site analysis, studying the building position and taking advantage of shading and natural light, building technology, and durability, insulation, performance, and longevity of the building, clean air and healthy living, and some sustainability. Okay, so way back in 2017, pre-pandemic, my family and I started to look for a potential property to build a new home. Our previous home was a larger house, a series of different additions, and had a very steep backyard with some wasted space, and it wasn't very inviting for outdoor use or guests. So I went to look for, or had the idea, the approach to look for a smaller lot, flatter lot to build on, and to create something that was a more efficient space, a little more smaller project, and downsize. At least that's the way I pitched it to my husband, and he might argue that I didn't quite get there downsizing on the project, but we'll talk about that at another time. We narrowed our search to the Allendale neighborhood. There's a lot of amenities and restaurants and schools, grocery stores, et cetera, all in this area that are easily accessible. It's a very pedestrian-friendly neighborhood for walking and biking. There is a H-E-B here, and Amy's Ice Cream for the kids, Twin Liquors for the adults, Shoal Creek over here for bike paths and walking. So we really like this neighborhood a lot. And we found this property that was for sale and took a closer look at it. This is the house, how we saw it when we first looked at the property. It has original 1940s house on it that was approximately 900 square feet with a pretty flat lot. As I mentioned, it only had about 3 to 4 feet of slope from front to back of the house. And so it checked a lot of the boxes. As we looked closer, I did have some concern over 2 of the trees on the property. First, this ash tree that's in the front of the house. As you can see, it's a rather large tree right here in the front of the property. As we had an arborist to the site, and as we looked closer, we learned that the tree was actually, this was wintertime, it had no leaves, but as we got a study from the arborist, we learned that it was actually dead and the tree had to be removed. So then the second tree, which doesn't look too large on paper, was this cedar elm in the back, kind of, a third weight of the property. But the canopy was huge. It had this great big canopy that extended into over halfway of the property. So it extended, way into here. And I knew it'd be a challenge to build around and limit the footprint of any potential house. So we sat and thought about the property for a few weeks. Again, remember this is 2017, you can do that sort of thing. But eventually came back around and took the challenge to design around that tree and on this property. So we purchased the property and got started with design. This is, I'm showing here the house was small enough because it was 900 square feet. We did some research and found that there was our organization called the Reuse People of Austin that you can donate the house to. So we donated the house and they came and lifted the house and put steel beams under it, disconnected all the utilities, and got it ready to be relocated. It ended up in Wimberley, Texas, for its next life. They prepared the house to leave, which I was glad to see, around 11 or midnight at night. So it was during daytime, because I had this whole time this great fear I would see this house on a Monday morning stuck on the Mopac Express lane, blocking out the traffic. So great group. They knew how to do it and took care of all those things. This is the property once the house was removed and just kind of open. It became springtime and you can now see the leaves on the tree and how far it really extends into the site, and the challenge I had ahead of myself. but it also became, I fell in love with the tree. Once you see it, you can tell how beautiful it was, and it was really special. And at this point, I knew that I would focus a lot of the design around this tree. And speaking of challenges, so we did, during the design process, we did a soils report or soil testing. And it turns out that I have some of the worst soil in Austin, which can be common around the Shoal Creek area or other creeks around town. They just, lots of clay and it's very expansive. So we had to remove 4 feet of the soil and replace it with more stable soil. I think all the neighbors thought we might be building a community pool when they saw this huge hole in the ground. Sorry, it's not a pool. Okay, so backing up to the design process, I'm going to talk about some of the inspiration of how I approached this design and the concept behind it. I began the design with an idea of doing this like nice, simple, mid-century modern house. This is an example of many that are out there that I just showed here, but I've always really loved the brick detailing here and the roof angles and window placements and all the things that are quintessential mid-century modern. Also strongly believe in having lots of direct access and views to the outdoors, and how it benefits moods and health and overall well-being of the families, which of course is one of the principles of mid-century modern architecture. That's when you finally started seeing houses open up to the outdoors and seeing lots of natural light in the houses. I've had great appreciation for the materials inside the mid-century modern houses, with terrazzo flooring and brick, stained wood finishes, exposed beams, clean lines, open plans, and lots of color. So I had this, concept in mind approaching the site, and I started to really look a little closer and analyze the site. So I identified, wind patterns, summer wind and winter wind, and where it might be good opportunities to place porches or any outdoor areas. I located all the setbacks and easements around the house, the front setback, and started to narrow in on the buildable area. Looked at the sun pattern of east. This is the front side of the house over here, and studied the sun movements of the house and where it was good to, position the house. I wanted to get a very, the standard west-east orientation that helps protect the south side of the house from direct sunlight. But once I put in the protected trees, my footprint kind of became this little L shape. It has this little angle here around the tree to preserve the vertical root zone of the tree. During conceptual design, knowing that this tree would be my focus, I really concentrated on trying to get all the, the major spaces, the primary bedroom and office and kitchen and living spaces all right around this tree. Also, this was my main area of having direct contact to or connection to the outdoors through windows and doors and glass. I attempted several options with this more orthogonal plan. This is just a screenshot of the Revit file early on. Trying to go back to that original inspiration that I had. But I just found that this shape kept limiting some of the backyard space, and I wanted a little bit, usable area for the backyard. So I went back to that original concept that showed that L shape, and that the angle in the plan ended up being in the final design, which is solidified as a 21-degree angle that shows up in the plan. And that, I started playing, it ended up to preserve the tree, but it became a playful element for the house to create different voids or volumes and 3D shapes and things and different angles that appear throughout the rest of the house. Also started to really study the shading of the house. So this being the front of the house facing east, we'll have some direct sunlight. And so I provided some covered areas that, cover the windows high. There's a balcony here that protects some of the glazing here. There's the brick screening that creates both privacy and shading. But the real concern is on the west side of the house. South side's more protected, sun's high in the air, overhangs protect the house a lot more. But the west side is where it can be really exposed. So I have the garage placed back here to protect the house. It's a detached garage along with this blue shaded area, it's a covered area. So it really helped protect a lot of the back side of the house from the west sun. I had some exposure here where I really wanted that outdoor connection, and I had a lot of glass in this area. But I took advantage of the tree. I mean, the tree canopy was really large, and I put that in my calculation of how much shade it would provide the house. I have an outdoor covered area here that also helps protect the house. And so at the end, the house from all sides ended up having pretty good shading, screening from direct sunlight coming in through any windows that really heat up the house during the summer. Here are just a couple of photos, but you can see this is an evening shot, and you can see that the canopy shade is coming through into the house here, helping shade the house. And over here, this is the edge of the outdoor or the detached garage that you can see it shading the house here, and these overhangs shading the house, including the canopy over there. There's my dog, Cairo. Oh, by the way, so this corner window here is a low-end lift and slide. And it was quite the challenge for everyone. So it's self-supporting. It works like a curtain wall system. And so there's two sliders that slide this way and here. So it's engineered to act kind of as an arch to add a little more exciting build for them. This side of the roof is sloped. And so it's an L shape with a slope in it. So I had a lot of things to figure out, but Lowen really did a great job of opening the space up, or helping me open the space up, which changes everything once we open those doors, which we use quite frequently. Changes the flow of the space and just the feel of things inside there. Another challenge was this screening here that I wanted to provide some shading and some privacy, but also have a good amount of natural light coming into the dining area. This is another one where my contractor Ford stepped up and really helped figure out these details. The first challenge we had was filling in the 16-foot tall void of windows. And so we had to find a window system that could support itself in the 16 feet, but also casements that open inward. A lot of casement windows open outward. And so I had to find some that open inside. So we were able to clean inside the windows. Second challenge of the screening was the lateral load. So this whole area is void of any brick ties. And so with the help of the contractor, we concealed some steel bars in the system that help with the lateral load of the brick. And then, well, the last part of this is finding the perfect balance between void and solid to let in enough light, but not too much light. I add some privacy to it. And this was a photo shot during construction that we were laying out different patterns in the driveway of the house. And we came up with all these different, ideas. But of course, this was the one that landed. I found out after this was constructed that the term for this type of brick screening is called hit and miss. I was referring to it as a breeze block, but I knew that wasn't quite right because breeze block is a concrete block that has voided shapes or whatever. And so if you were to look up these different patterns, you can Google hit and miss brick. This is looking a little closer at the floor plan, and the Shaded area shows the areas or the spaces of the house that were angled at 21 degrees to clear the tree. And everything to the north of that is more on orthogonal, parallel to the property line. So tree here in the center, primary suite, office sitting right here, kitchen, living room, outdoor dining, everything, you know, has really good connections to this outdoor space. On this side is a guest bedroom, dining room, and here's the detached garage with a little sunroom. Cool. On the second level, this is the roof below the tree. So I pulled the walls of the second floor back to allow the canopy to extend over the first level roof. And so this is showing the first level roof where the tree extends beyond it, has, you know, a chance to continue to grow, and how I pulled the house back a little to give it a little breathing room. A couple of pictures, and this line right here shows there's a still bar in the floor. You can see that everything here on the left is on that 21-degree angle, and everything on the right becomes more orthogonal, parallel to the site. And the line above is the second floor that is pulled back for the space of the tree. And you can see how that tree goes over the canopy or over the roof on this side, and where the second floor is pulled back. This is just a shot showing that how once that angle became part of the plan, I just started to play with it everywhere. So this is how it appears on the front of the house with the winged roof and the angled balcony. It just became a playful element for me through the process. This is the roof plan, showing also again the angles of the roof and how they, you know, relate to the site. I had I had an interesting request for my contractor and landscaper. The lot is high at the front of the house, and it all slopes basically directly to the back. And with the idea of preventing runoff of water of the house, I asked the contractor and the landscaper, I'm like, it would be great if we could just somehow get all the water, rainwater that's collected on the roof back to the front of the house. And the landscaper was like, yeah, no problem, we can do that. And so what I thought was going to be this huge challenge, and I would have to get civil engineers and a lot of people involved, became actually pretty simple in concept. So this area here is the second floor roof. Water slopes down to here to this gutter, which falls to the lower roof and comes down to a rain chain and flows underground back up to the area of the critical root zone of this tree. So all this entire area, probably like 2/3 of the roof, comes back to the front of the house and has a chance to be recaptured as it flows back down through the site into to the grass and in the critical root zones of the house. There's a little portion of the roof that is piped over into some of the driveway area here. And all this area of the driveway, where it's slightly shaded gray, is meant to recapture water on the site as well. And these little cutouts in the driveway ribbon are intentional so that water can flow through the site. And it works really well. We never see any ponding water or any holding water going off the site, which is important being close to Shell Creek and preventing as much runoff as we can. These photos in here. So I spent all this time designing this great, roof that helps recapture water and shade the house. And a moment during construction, my kids jump out this window and are playing on the roof. And so here is my oh crap moment, standing there, like I provided a direct escape route for my kids to sneak out of the house, going down the roof to the low part of the roof here. So now the house has alarms and chimes on the windows in case that window opens, just to make sure. Okay, so moving on to building technology. These are 4 principles or basic concepts that can be applied to really any house or structure and sort of building. I have, well, here's the built house. Here it is under construction and a wall detail of the house. So this little narrow area of an exterior of the house has a ton of responsibilities. It protects the house from rain and sun, temperature, humidity, moisture, air leaks, allows natural light into the house. It also defines the character and style of your house and your finishes of the house. So there's a lot going on right here. So the first layer of the house is just your exterior material. It's the first line of defense, protecting from sun and rain. Of course, you want to specify materials that are require little to no maintenance. Try to avoid painted wood or trim fascias with windows and those things that deteriorate with the sun. All these materials here are great for holding up against sun and UV, and they require, you know, they're not painted materials with stucco, but there's not a lot of maintenance here. There's metal fascias. And so, you know, all of these materials should hold up for a really long time. By the way, these panels are an Acme product that are from, it's Acme terracotta clad system. It's a rain screen panel that are on channels. That it's been a great product and interesting to use. Also, real quick, want to point out why this photo is here. I want to point out the shading, how you can kind of see how, you know, this big wing of the roof is hitting these high windows here and there, doing their jobs, preventing wherever they can any direct light into the house, reducing the amount of heat that gets in there. Okay, so back to the wall section. So first layer is your exterior material, whatever it is. The second layer is a air gap or a drain layer that allows any moisture to breathe out, or any moisture that gets trapped behind to breathe out, preventing the, you know, any water affecting the materials or deteriorating the materials in your wall assembly. This gap also provides a bit of insulation because of the air and the breaking the thermal bridge between the material. The third layer is your weather barrier. So in my case, I did, it's called Delta Band. It's a peel and stick product on the house, and it works well. There's other products like this, but it works well because the way they layer the material, lap them, and it sticks. And so it really seals up the house, protecting it from vapor, moisture, air, etc. They are some, you know, other house wraps out there that are not peel and stick, and the way they are stapled on, they provide, you know, a little loose areas where the materials lap and air flows through. So these peel and stick or liquid applied are really great materials for sealing up the house. And then the fourth layer is your, well, let me go back to the air barrier. So the air barrier is the place where you want to control your condensate. So condensate, of course, happens where, you know, cold air or meets warm, humid air. And so you want to keep that on that barrier on the outside of the house. So if there's any condensate that happens, it happens at this layer of the house, and you have that air gap on front of it to allow the moisture to dry out and preventing from getting inside the house. Fourth layer, of course, is insulation. There's continuous insulation using the zip R panel here that protects the house from thermal bridging and really helps insulate the house. So between having, you know, these steps can be applied to really any product. I mean, you can look at exterior stone, lap siding, stucco, whatever the material is, all those materials have some absorption of moisture through them, or they wick moisture behind it. So having that air gap behind it really helps dry out any of those materials that you use. Just a couple of shots of the inside the house when they did the insulation. I used Bibs insulation, which is blown-in blanket system. It's really great at filling in all the little gaps and going around electrical outlets and things like that. It's resistant to moisture and mold growth. It can bring out any moisture that gets in there. It's non-combustible and formaldehyde-free. So it's a great product that we've been specifying on many of our projects. Spray foam is a good product because, well, it has great insulation. It also works as an air sealant from the house. But it does off-gas some VOCs. So it just depends on our client if they have any sensitivity to VOCs that we might, push them to do the Bib system instead. All right, moving on to clean air and healthy living. We spend a lot of time in our homes, especially now that we've been working at home more during the pandemic. The average person spends up to 34 years in bed and half of their lives inside their home. So it's important to have clean, fresh air in our homes at all times. So we do our best to prevent any pollutants seeping into the house, as well as provide good air filtration to capture the dust and pollutants that get in the air. These systems go through the air barrier sealant, dehumidifiers, ERB, and air filtration. Help achieve a good quality, healthy environment for the house. Okay, starting with the air barrier system. This is a cool product. So they use this, vapor that they put in the house. It's water-based, the mist that is sprayed throughout the house that effectively seals any leaks throughout the house. And so it fills gaps 1/2 inch or smaller. And so they pressurize the house, put in these misters, and just leave it on for several hours. And you can walk around the house and see, like, there's a major hole in the house you can identify because you can see the mist coming through. But, as contractors, as hard as everyone tries to get, there's always cuts during, electrical outlets or on windows, or little things that we miss that we do in the seal. And this system seals up all those, different types of areas where you just can't visually see where there might be holes in the house. So this provides a good sealant to the house to allow it to stay dry and clean and protect it from both moisture or air coming in that carries moisture and pollutants, et cetera. The next one is a dehumidifier. As we know, we live in a very humid climate, and year-round, we have high levels of humidity outside. The ideal humidity level inside the house should be around 40 to 60, which often, of course, is not outside. So to help maintain that environment inside, we use dehumidifiers. We could do a whole hour of just all the benefits of having a dehumidifier and dry air in the house. They help reduce mold and mildew, bacteria. It helped reduce, surprisingly enough, insects in the house and different types of pests. It preserves finishes and furniture, preserves your bedding and clothing. It helps with dust and dust mites. There's a lot of benefits for having a dehumidifier in the house. These systems also help the air conditioning systems run more efficiently because it removes the moisture in the air, and the AC is not having to run overtime or additional hours to continue to try to pull moisture out of the air. So having this system in the house makes your HVAC more efficient. Next part of that is including a ERV, which is an energy recovering ventilation system. Please don't ask me exactly how it works. what I know about it, it transfers, it brings in fresh air from the house, but it removes moisture from the air, and it filters the air. And so it brings in clean, dry air into the house, and it exchanges it for, it removes air from areas that are known for, having more moisture, like bathrooms and laundry rooms. So this system pulls all air out of the bathroom and replaces it with fresh, filtered, clean, dry air. We'll have one in the house. Sometimes you can place, multiples, and just depending on the size of the house. But it's a great way, because these houses we build now are so sealed up, a great way to bring in fresh air inside. And then the last part of having a healthy environment is just the filtration system. Having a MERV filter in the house they really do filter out a lot of pollutants in the air. MERV is just a rating devised by ASHRAE just to determine the amount of particulates it's removing from the filter. Once you get into a MERV 13 and 14, it really removes a lot of things in the air and keeps your air pretty clean. Once you go beyond, I think, MERV 14, you start getting into systems that are HEPA filters, which are systems on their own that supply, clean air to the HVAC system. But between MERV 14 and HEPA filter, there's only like 5, maybe 10% difference in how much of the pollutants and particulates that it removes from the air. So having a 13 or 14 really does the trick. Okay, so moving over to sustainability a little. I want to talk about the systems that I have put in my house that help make it efficient and sustainable. I do want to point out that I understand that my house is not the most perfect sustainable house. I like nice things. I like having lots of windows and having a pool and heating and cooling, and I like having guests over and throwing parties. And so, but I do want to point out the things that I have done that really make this a very, energy efficient house. And at the same time, to keep all the parts of the house that make it fun and the things that I like at the same time. So before I dive into these types of systems, I want to touch base a little bit on our Tankless electrical grid. I think in general, the word sustainability can be very confusing to people. There's a lot of information out there, and it's hard to know or sort through all the information. We're all trying to do something better, but it's really hard to know the impact that we're having with the decisions that we make to be more conscious or be more sustainable. So I always like to argue, and probably most experts will argue, is that our biggest challenge, and probably our emergency challenge, is to reduce the amount of fossil fuels that we're putting in the air. It should be our #1 priority to fix, just reducing whatever carbon we're releasing in the air. So when I, approach ideas of sustainability, I really have that one at, top of my mind. Of course, we still want to conserve water and reduce landfill and reduce air pollutants and recycle materials and so forth. I'm not saying those are, we should forget about those, but carbon being in the air should be our #1 priority. So, where do we start? How do we do that? You start with electrifying our buildings. My house is fully electrified. I even have a gas meter connected to it. It's the appliances and everything in this house work great. I know and I run into this with my clients, that everyone, loves cooking with gas. And it's how could we all grew up with our grandmother's gumbo or stew, seeing that blue flame, and how could that food taste so good without that blue flame underneath it? But it does. you can still cook food and have good gumbo without having gas in your house. So, okay, briefly, this chart on the left, which is a little outdated, but shows how Texas generates its electricity. And clearly, you know, there's a long way for us to go. There's quite a bit of natural gas, coal still that's being used to generate electricity in here. But at the same time, you know, we are increasing our wind power. I think the solar, you know, is a little more than what this 2% is showing. Right now, Texas uses about 33% renewable energy. And it's projected in, I believe, 2030, that will be around 40% of renewable energy. So quietly, our Texas grid system is moving over to renewable energy. And we want to support this in every way we can to reduce this natural gas and coal. The second chart just shows, you know, where building use is in 30% residential and 29% commercial. And these are areas where we can really make an impact and a difference of changing our systems. Interesting enough, Austin Energy does a pretty good job of sourcing renewable energy. So this is a screenshot that was done back in August. So you can go to this website here, and every 15 minutes, I believe it updates and tells you the exact source of power generation and where it comes from. So sometimes it's half of this, but I like to throw this in here because, you know, there's hope. Like, we can get here. We can remove this last little piece here of the non-renewable part and move over to all renewable energy. Interesting enough, when I was talking to Austin Energy Green Building about this chart, I discovered that Austin's #1 energy use is the water production in the city of Austin. So the process of pumping water and filtering it, et cetera, is the #1 use. So by conserving water, you also conserve electricity. Let me go. Okay, so this is moving on to the types of systems that will, you know, help support our electrical grid and moving over to renewable energy. The first step or concept of all these systems is that they are energy sipping systems. They don't, you know, you can schedule them to be used at certain times, but they also turn on at lower speeds and have variable speeds. So starting with the mini split, which is a variable refrigerant flow and a variable air volume, which all means that it uses the amount of energy and fan power needed to cool and heat the house at that time. And it just doesn't come on and off at full speed. Another advantage of these mini splits is that they can be zoned, and you can turn them on to be used as, you know, nighttime you would cool or heat bedrooms, daytime it would be the other spaces throughout the house. Each one of these outdoor condensers can hold up to 4 interior air handlers. So for example, I have a system that is split between 2. One controls the bedrooms and one controls the living. So during the daytime, you turn one down, turn the other up. And so it's just not running the entire house. I have this photo in here. One of the challenges that I had was to, well, heating and cooling this space. I concealed one of these units right here behind these shelves, and the air register is concealed right there. So that's where I got one of those eyes from my contractor, like, you want to do what now? But it works great, turned out very well. And that was lots of thanks to King Wood Cabinets for helping figure out that detail. All right, another cool system is a heat pump water heater. These systems draw air from the surrounding air into the unit and remove heat and collect the heat for water heating and discharge cold air. They're, you know, very super energy efficient, work well, and they have 4 stages of heating. So it stays on a very, very eco-friendly mode. But if you need additional heat, if you have, you know, people taking showers at the same time, it kicks in and supports that need. This is a great appliance to be put in houses because it can be scheduled to be used during off-peak hours in the mornings and heat up and then store the energy throughout the day. This just shows real quickly how I essentially located the water heater in the house to reduce the runs of the piping to the areas that it is serving. So primary bathroom here, guest bathroom, and kitchen, with the idea of removing the need of a recirculation pump in the house. Same idea for the air handlers in the house. They're essentially located to reduce the run and power of the fan needed to get the ducts to the spaces they need. And this is just showing the same diagram upstairs where the water heater is below and just serving the two bathrooms right above the second floor. Another system for the pool. This is a variable speed water pump that's Energy Star rated. So I start the pool cleaning system around 4 a.m. in the morning, and it starts at a certain speed, but through the day, because it's variable speed, it ramps down until noon. It just shuts off completely. So I use it during non-peak hour times to help the grid system. And this is a heat pump water heater, very similar to the heat pumps that we use for heating and cooling our houses. It's an efficient system. So instead of using gas, it uses electricity. So to offset all these, appliances and nice things that I have in my house, I have been installing solar panels. We provided an entire year of energy bills to our solar installer, and they calculated the need for over a year and designed the system to be net zero at the end of the year. So hopefully the system will, work out. They're just installing it now, but the goal is to all the energy use I have will be net zero at the end of the year. So summary and point I'm trying to push here is that we can still have nice houses and we can still have, our great natural light and all our appliances and things like that, but there are a way to schedule them for non-peak hours and to install solar panels and things like that to make it net zero. Another point to make is that all these systems, although I did it new in my house, can be retrofitted and installed at any point in any house. So for example, if your water heater goes out, then install it with a heat pump water heater and slowly replace these different types of appliances that are smart and work with our system. This is a couple extra photos showing placement of windows and how they're high to the ceiling interior, which really bounces the light against the ceiling and draws in natural light throughout the entire house. Here's inside this office I'm sitting now. And so it eliminates the use throughout the day of artificial lighting or electrical lighting. Another shot of the hit-miss brick here in the dining room, showing there's a ton of light. There's a lot of windows in here, but there's no direct sun, and it's also very private the way the windows are positioned. So you can sit in the dining room and you're not really seen by the neighbors, but have lots of natural light. And lastly, here's a picture of my husband. Wanted to say thank you to him for putting up with me, let me convince / trick him into building this house. And by the way, if you show up to the house during the tour, we'll both be there, but Michael will be in the backyard near the greenhouse. And if you'd like to talk about plants, he'll talk to you all day long. So find him. And that is the end of the presentation. Thank you, everyone. I hope to see everyone on the tour weekend.
Yes, thank you so much, Jed. That was an amazingly informative presentation. I feel like I've learned a lot. I hope everyone else has. If you have any questions, please put those in the Q&A at the bottom. Right now, we don't have any questions there, but I have a question for you. I was wondering, so one thing that is so interesting and why people hire architects is that you have, in addition to all your knowledge about all the things that you can buy, your thoughtfulness in placement on the site and locating windows. And and the overhangs and all of that. I was wondering if you could just speak a little bit more about, if say you don't have the budget to put in all the bells and whistles. Do you feel like just the designing and thoughtfulness can offset some of the energy costs that you would get otherwise?
Sure. Yeah. So this will, plug or promote all architects out there and the value of the designs. I mean, you can take all the pieces and parts of this house and rearrange it and make it could be a very, hot, inefficient type of house. And so by placing windows and things in, proper areas that are shaded, but still maintain good visual connection to outdoors, the same cost of the house, but then you have a very energy efficient house. And so I think the savings in just energy alone covers the cost that anyone would spend on, an architect, just having, that value of the house. And the building science behind the materials and the wall assemblies that really, support and keep the air inside, healthy and clean. All those, are great values for hiring architects.
Thank you. Okay, we have a couple of questions here. Alexandra asks, was there something else you wanted to incorporate in the house design? Could you incorporate it in the future if you wanted?
I'm not sure if I understand the question. Is that incorporating like additional space or additional systems, or I get the question a lot of what I would do different. And living there, you're constantly redesigning the house. My footprint was my footprint, so I'm always exchanging, like, what if I made the this room a little bigger, but then it would have made this room smaller. So I'm constantly going through, like, if I could rearrange spaces throughout the house. But overall, like, I think it really works out. I put a lot of design into the the spaces that our guests would enjoy, and I wanted that to be my priority. And I kept bedrooms smaller and utility spaces smaller to maintain or capture enough space for where our lifestyle, how we like to entertain. So I don't know if that answered that question.
Yeah, I think that was great. We have a couple more questions. Tatiana asks, making the house net zero, is there timeline for return on the initial cost in the calculation? So I guess, is there an ROI?
I believe it's a great question, and there is, and I believe it's it's out there. It's like a 10-year ROI, or maybe about 8-year ROI. So it's one of those things that ROI is important, but it's also, like, for myself, is important to do. I have the means to do it, so I want to be responsible and do the things that I know that I can help our environment. I have a larger, roof plane on the second floor, intentionally designed to face, the south and angled the right way. And so I have a ton of panels. So it was an expensive system, but there is an ROI about 8 to 10 years, I believe.
Yeah, and I think even just living and being comfortable in your home, that is also adding value too. Okay, so we've got one more from Catherine. Did the dedicated dehumidification work well in the spring and keep the house dry when your AC didn't need to run?
Yes, so the way they set up these systems, they're at the base of the air unit, at the air plenum of the unit, at the return duct. So it will draw its own air without the system running through the house and recirculate it and drive the house, the air in there. It runs less in the spring because it's a little drier. But I think there's 3 dehumidifiers in the house, and We know we have a lot of people come in and make a note that it's like, oh, the air feels really like dry and clean in here. What is it? And so I feel it, but it's interesting to see like different people who come in also know the difference and how good that feels to it's just more comfortable to be in.
Yeah, I've heard folks say, your air conditioner is a dehumidifier, which is true. But I was curious if you could speak a little bit more about the benefits of not using an air conditioner as a dehumidifier.
This is where I really wish I had Positive Energy, the mechanical engineer here, because they could speak so well to this subject. They would probably argue that air conditioners are not humidifiers. It works that way in the process of cooling, but primary goal is to cool, and that a dehumidifier should be separate. And so, there's also projections, or there's new equipment coming out that I've seen that they're combining dehumidifiers with air conditioning systems. I don't know if they're quite out yet, and I don't know if I quite trust them yet, because like one little part can go out on your dehumidifier and then you don't have any cooling. But they're, we'll see, maybe they'll work great. They're coming out there. But you really have to think of them as separate systems. And, we architects have been in a lot of seminars and learning over the years that don't rely on the AC to do your humidification and get those different systems in there to balance it out.
Awesome, thank you. And then we have a question from Jennifer, we have a couple more questions. So Jennifer asks, can the dehumidifier be added to most existing HVAC systems, or is it something that needs to go in with a new system?
Another good question. I wish we could call Miguel at Positive Energy here. Our new results, the mechanical. Yes, my understanding is that you can retrofit it to any house, and it doesn't necessarily have to connect to your air conditioning system as well. It can be an independent where you can add it to several rooms in the house and help run separately. So it can be added, and I suggest everyone add them and realize like how more comfortable and efficient your systems will work with them in the house.
All right, we have another question from Alexandra. Did you also consider installing a tankless water heater versus a heat pump?
I didn't do tankless because it uses gas and I have no gas on the property. I believe there are electric tankless, but the most energy efficient one are those heat pump water heaters. And so it was a clear choice for me to pick something that was that energy efficient. Those heat pump water heaters are interesting. So they work very efficiently, but they produce, the byproduct is cold air. And so they work great in garages actually, because there's a big volume of air and it can draw air. It's typically hot year round. And so it can remove heat from the air. But in smaller spaces, if it doesn't have enough volume, it'll make the room too cold, the byproduct. And so you'll have to vent the air outside so it doesn't make the space that it's in too cold.
It's an interesting fact there. All right, that was our last question, and it looks like we're right at our time. So yeah, we've come to the end of this webinar. I want to thank you, Jed, so much for sharing all of your knowledge to all the architects and everyone listening who is going to go on the tour of your house and probably have a lot more questions for you then.
Great. Hope to see everyone.
Yes. Thank you all. And thank you to the AIA as well.